In this video, we are going to talk about beacons. But first, before we explain what beacons are, let's see the following scenario. Let's suppose that you are in the mall shopping for new clothes. You are walking around the store searching for what you need. And the store has beacons installed all over the place. And suddenly you enter the range of one beacon. And for some reason you receive a notification on your phone. This notification informs you that there is a big sale on the items next to you. The concept of beacons originates from the simple lighthouse application in the real world. Lighthouses send light signal in order for ships to discover it and be able to tell where their location is. In a similar fashion, a Bluetooth beacon sends out advertising packets for other devices to discover it. Ooh, what is this? Beacons. What are beacons? And how can they work? And when did this technology appear? Of course it has many applications. Tell me, how can I use it? Ooh, it is time to find out the answer to the question. Beacons are Bluetooth low-energy devices that broadcast advertising packets. This is especially important because the use of less energy means the ability for the beacons to be actively used for longer periods of time, often years, without changing the battery. Now the data sent in the advertising packet varies based on the standard being used. In general, a unique identifier is included with a namespace identifier. Think of a namespace identifier as a number that indicate a location and an area within a specific location. A common misconception and met with beacons is that they are able to track users and mobile devices. Beacons cannot track devices in general, because all they do is send out advertising packets that allow the other devices to discover it. Now, we want to know, how do beacons work? First, beacons broadcast a unique identifier over Bluetooth. Second, smartphone reads the unique identifier. Third, smartphone wakes up the beacon-enabled app. The app recognizes the beacon through its identifier. And then the app reacts. And finally the user receives the information. Now, we want to know, what is the physics behind a Bluetooth smart beacon? What is a beacon like on the inside? A beacon is designed with three major components: a small ARM computer, a Bluetooth smart connectivity module, and batteries for powering the entire circuit. The CPU of the ARM computer has an antenna attached to it, which broadcasts electromagnetic waves with specific length and frequency. Now, let's talk about the kinds of beacons. There are many kinds of beacons, such as indoor beacons, long-range beacons, keychain beacons, pocket beacons, and outdoor beacons. Now, let's talk about the beacon's activation. Depending on the kind of beacons you are using, as we mentioned before, the activation process will vary. Some of these requires you to insert batteries, whereas some of them have inbuilt batteries. Now, we want to know together some terms related to beacons. The first thing is the transmission power. Transmission power is a measure of the level up to which a beacon can transmit signals. The TX power of a beacon can range from -30 dBm to +4 dBm. Let's see together the maximum range of different beacon hardware types at a transmission power of +4 dBm. The maximum range of indoor beacon is 80 meter, and also the outdoor beacon has the same range. On the other hand, the maximum range of pocket beacon is 50 meter, and the maximum range of keychain beacon is 25 meter, but the long-range beacon has the highest range. The maximum range of long-range beacon is 300 meter. The second term we want to know together is advertising interval. The advertising interval determines how often packets are being broadcasted by the beacon. The interval is approximately 1/10 of a second. And finally, the third term we want to know is the battery life. Beacons have long battery lives of 2 years, when they are set to their default configuration. Transmission power and advertising interval affect the battery life of a beacon. Transmission power is inversely related, while advertising interval is directly proportional to battery life. Now, let's talk about the big beacon battle. iBeacon versus Eddystone.
First, to prevent any confusion, let's say again what is a beacon. A beacon, in general, is any device that transmits a Bluetooth low-energy signal, which allows another device to determine its proximity to that beacon, or receive a notification from it. Where iBeacon is actually nothing more than Apple's trademark that refers to the beacon protocols and devices that Apple created.
iBeacon is a Bluetooth Low Energy protocol that was created by Apple and was released in 2013. Since it is the first official protocol, almost every beacon supports it. It's officially supported only by iOS, but you can find many APIs that also allow Android to scan for iBeacons. If you want to do any action with them, the user must have your app installed. iBeacon's signal contains 3 main pieces of information: Unique Universal Identifier, UUID, the beacon's most general information. Major, the beacon's most general spatial information. Minor, a more minute piece of information. You should never have 2 beacons that have the same UUID, major and minor. Now, since we know the main 3 pieces of the iBeacon signal, let's explain them in details. The UUID is the signal that is actually being sent by the beacon, and it is an identifier that distinguishes your beacon from others. For example, one company will have one UUID for all the beacons they own, and another company will have another UUID, and so on. The major component, on the other hand, is an optional component, which specifies a particular beacon within a group. For example, if you set a major value of number 1, this could refer to beacons only in your store in New York, and major value of number 2 could refer to the beacons in your Los Angeles store. And finally, the minor component gets more detailed. So the minor value identifies each beacon in your store. The beacon at the entrance of the store can have a minor value of 1, while another beacon at the back of the store could have a minor value of 2. While the Eddystone format is a new and open communication protocol developed by Google in 2015 with Android users in mind. It officially supports both platforms, iOS and Android. Much of how Eddystone works is the same as iBeacon. But there's extended functionality beyond that. Eddystone exists as 4 different frames: Eddystone UID, Eddystone URL, Eddystone TLM, and Eddystone EID. The UID works more or less exactly as iBeacon does. It broadcasts a short code at a regular interval. Eddystone URL broadcasts a URL that can be viewed by anyone with a Bluetooth-enabled smartphone whether they have your app installed or not, and Eddystone TLM broadcasts some telemetry data about any attached sensors and the status of the beacon itself. This could easily be used to power data collection or triggers. In short, an Eddystone beacon does nearly everything iBeacon does with some added features. In conclusion, Eddystone sends 4 packets. Unique ID (UID), which is a unique static ID similar to the UUID, majors, and minors with 2 parts, namespace and instance. Namespace ID is unique per application and would be the same for every beacon deployment in that application, while the instance ID would be unique per beacon device so that your application can determine whether its beacon is at the front door or at the back door. URL, which includes a compressed URL that can be directly used by the end user. TLM is another packet not found in iBeacon. It contains telemetry data that's great for fleet management purposes. And finally, EID is an added security measure. As we know, beacons are devices using the Bluetooth Low Energy technology. BLE and Bluetooth, referred to as classic Bluetooth, uses the same 2.4 GHz radio frequency bands. And form wireless personal area network for communication. There are many differences between BLE and Bluetooth. But the key difference between them is the low power consumption in the BLE. It is an important difference as it preserves the device's battery. Another difference is the rate of data exchanging between the devices, as it is 1 megabit per second for the BLE, unlike the Bluetooth, which exchange data with rate 700 kilobytes per second. So, BLE transfer data faster than classic Bluetooth. The covered range by each of Bluetooth and BLE is relatively different, as BLE covers about 50 meters, unlike Bluetooth, which covers only about 30 meters. The actual connection time between the two devices for BLE is only few milliseconds, unlike Bluetooth, which would take about 100 milliseconds. Regarding the transferred message size, BLE is more effective for exchanging small chunks of data as it transferred them with maximum message size about 47 bytes, unlike Bluetooth, which transferred the message with maximum size 358 bytes. Now let's talk about beacons' role in tracking, and the difference between them and the GPS. Before comparing between GPS and beacons, let's give the GPS a brief description. This global positioning system is a satellite-based radio navigation system used by the militaries of different countries and emerged as one of the requisite function of the smartphone. Now let's discuss the difference between GPS and beacons. Beacons provide high accuracy for the indoors, unlike GPS, which lacks accuracy as it is susceptible to obstructions. Beacons cover a limited range, about 50 meters, unlike GPS, which covers an unlimited range. Beacons consume lower power range than GPS, which preserves the device's battery. Both of beacons and GPS have low cost. Beacons are best for the indoor tracking, unlike GPS, which is the best choice for the outdoor tracking. We are in the year of pandemic. You are meeting many people every day, and around them maybe there's someone who got infected with COVID-19. How could we make use of beacons to stop the spread of COVID-19? Preventing the spreading of COVID-19 could be done using contact tracing. Basically, contact tracing means tracing all the people who have been in contact with an infected person. Let's see how it works. Let's imagine that you are in a market and around you there is a person who got infected with the coronavirus, but he doesn't know that yet. Beacons can help in tracing this state as follows. Each phone is turned into a beacon and has a unique ID, Beacons send signals to other beacons which got in contact with in a form of keys, and each phone records and securely store the keys it comes in contact with. This person has been confirmed to have COVID-19. He enters the test result in an app from his public health authority, then his phone uploads the last 14 days of keys for his broadcast beacons to the cloud. The app downloads a list of beacons associated with anonymous app users who have tested positive for COVID-19, then the device cross-checks those beacons with the ones it came into contact with. If a match is found, an alert is sent to you to inform you that you have been exposed to someone who has tested positive for COVID-19 and provides you with information about what to do next. But, wait! If beacon technology is that great, why it has not taken off the way everyone expected? To answer this question we gathered some potential causes. Installing, managing, and maintaining beacons in large numbers across a vast network of locations is a major undertaking that requires significant planning and testing to carry out. But even using beacons in a single location can present significant issues. Another problem that faces beacons is that the beacon's Bluetooth low energy signals are often obstructed by physical objects. As seen in the following demo, when there are no objects between the signal and receiver, everything goes well. But when an object gets in the way of the signal, beacons can function poorly and the receiver can lose the message. In order for a customer to receive a beacon message, they need to do a lot which may be annoying for some people. First, customers need to have their smartphone or tablet with them. And they have already downloaded the Stores app. And they have Bluetooth enabled on their device. And have agreed to receive in-person notifications powered by beacons. To recap, we talked about the use of beacons in the retail industry. What are beacons? How do beacons work? Beacons protocols. BLE versus Bluetooth, Bluetooth versus GPS, the use of beacons in contact tracing, and finally why beacon technology didn't take off.